Hi, welcome to the Olympiad Geometry. Let's continue our study on Orthocenter. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe the channel. Here is a problem. Let H be the orthocenter of triangle ABC. This is P. P is any point on the plane. HL, HM, HL, HM, and HN are perpendicular to PA, PB, PC, and meet line BC, CA, AB on XYZ respectively, right? So basically we have PL perpendicular with HL perpendicular with PA and meet BC on X, right? And HM is perpendicular to PB and meet AC on Y. HN is perpendicular to PC and meet AB on Z. We want to prove that X, Y, Z are collinear. So just look at the figure. We have the feeling that almost all the lines are associated with the point H, which means that H should be the key factor, should be the breakpoint of this problem. And what we can learn from this one is that because angle ALX equals to angle ADX, that means ALDX are cyclic, right? Once ALDX are cyclic, and we can consider AD as a chord and XL as a chord of the circumcircle of the quadrilateral ALDX, right? That means AH times HD equals to HL times HX. And we already know that from the orthocenter property, AH times HD equals to BH times HE equals to CH times HF, right? So we just expand our from to all the A, B, C vertices, right? So we have angle ALX equals to angle ADX equals to 90 degrees. So we know that ALDX are cyclic, which means AH times HD equals to XH times HL, right? Similarly, because angle BMH is, or BMY is 90 degree and angle BEY is 90 degree, right? So we know that BMEY, these 4 points are cyclic, which means BH times HE equals to MH times HY, right? Similarly, for point C, we have angle CNZ is 90 degree and angle CFZ is 90 degree, right? So CNFZ are cyclic, which means CH times HF equals to NH times HZ, right? And from here, it looks like we stuck, right? Because we just know that AH times HD equals to BH times HE equals to CH times HF equals to XH times HL equals to MH times HY equals to NH times HZ. looks like that we can get a cyclic quadrilateral from xh times hl equals to mh times hy. That means xl my are cyclic, right? X, L, M, Y are cyclic. And that actually just remind us that we can do this. So just to connect to pH, right? Connect to the pH and extend it to a point. Let's call it Q, right? So pH, we connect to pH and extend it to Q. That pH times HQ equals to AH times HD and equals to all of other terms, right? So that makes pH times HQ equals to XH times HL, which means P, X, Q, L are cyclic, right? And we already know that the chord PX reference to a circular angle PLX and a PQX, right? So angle PLX equals to angle PQX equals to 90 degrees. So that means XQ is perpendicular to PQ, right? And similarly, we have PH times HQ equals to BH times HE, right? So PH times HQ equals to BH times HE. That means PQ, BE are cyclic, right? PQ, BE or EB are cyclic. Wait, am I right? Yeah, but this is not what we are going to use actually. I'm sorry. Actually, we're looking for the angle PMH, right? PH times HQ equals to MH times HY, right? Similar to this one. We got this as cyclic based on that P. This one, we got this as cyclic based on PH times HQ equals to XH times HL, right? So this here we use MH times HY. So PH times HQ equals to MH times HY. That means PQ, MY are cyclic, right? PQ, MY are cyclic. And we already know that chord PY, the angle PMY reference to the chord PY, right? And angle PQY is reference to the chord PY. So we know that angle PMY equals to angle PQY equals to 90 degrees, which means YQ is perpendicular to PQ. YQ is perpendicular to PQ. And also PH times HQ equals to NH times HZ, right? So PH times HQ equals to NH times HZ. That means PNQZ are cyclic, right? PNQZ are cyclic, which means angle PNZ equals to angle PQZ, right? Angle PNZ equals to angle PQZ equals to 90 degrees, which means ZQ is perpendicular to PQ. So that makes it clear that Z, Y, X are the points on the perpendicular line that passing through Q, the PQ perpendicular line that passing through Q, right? So we know that X, Y, Z, Q are collinear. Okay, so for this problem, I think the most difficult part is that, so this is easy, right? We can easily find this. And the most difficult part is to relate all of these equations to pH times HQ, right? I mean, if you have enough experience, then you have the feeling that you can try something on the point P and make it related to H, and then it become very clear. Okay. I hope you like this video. I hope you like this problem, and see you in next one. Thank you.